Hi, in this video I will try to explain why higher voltage electrical system in electric skateboards are more efficient than a lower voltage electrical systems. So, for example, Evolve GTR has a 10S system. So it is a 10S battery. ON's Black Curve has 12S systems. And if we take something like Lacroix Stormbox SC, it supports up to 16S system. So why is 16S system is better than 10S and 12S? And you might have heard that the higher voltage systems run cooler than a lower voltage system. So let's talk about why. Let's start with just Newtonian mechanics. In order to move your skateboard with your on it from point A to point B, you need to expel energy. And a formula for energy is power multiplied by time. That's power over time. And let's say that it takes you an hour from A to B to get from A to B, and you need to spend 1,000 watts of power. So in order to get that amount of energy, we spend 1,000 watts multiplied by 1 hour. But you might have say, well, I have heaps more power than 1,000 watts. My skateboard has like 3,000 power watts motors, but that's the maximum power. Let's assume that's the power we're talking about here is what's actually expelled by moving you from point A to point B. So where does this 1,000 watts come from? Well, because it's an electric skateboard, it comes from the electricity. So the skateboard is electrical circuit which has a battery, right? And on the other side, there's some kind of load. Why do I say load but not ESC and the motors? Because in reality it's a little bit more complex than that. So ESC is not one, ESC and motor is not just one thing. In reality we'll have something, just let me erase this. In reality we'll have something like this. We'll have an ESC, and then we'll have another secondary circuit which goes over there, and there's going to be your motor, and there may be a radio receiver and some other stuff. And there's not just one circuit, there are two circuits, because the motor here, this motor over here, it doesn't run on the same power as your ESC. That's like this is DC here. Then the ESC converts it to the three-phase AC power with a secondary circuit. But for the simplicity of this explanation, we can just discard all of this stuff and assume that everything here, everything we talked about, is combined into just a single load. Load. That's all your ESC and everything combined. And we have a DC current running, say, this direction. So we know that in order to get you from point A to point B, we need 1,000 watts of power. So there are multiple ways to get this 1,000 watts of power. The formula for the electric power, I may be confusing the characters a bit, but basically power means voltage multiplied, not the U, voltage is V, right? That's voltage multiplied by current. Which means that there are multiple ways to get to 1,000 watts, for example, is, let's say, like 100 volts of voltage. So it's going to be 100 volts multiplied by 10 amps. which means that in order to get that 1000 watts of power with 1000 voltage, we'll need to run 10 amp current here. But at the same time, we can achieve that 1000 volts of power if we have 500 volts, in which case we only need 2 amps. So which one is better? Is 100 volt better or 500 volt better? So there's another formula. Not all the electric currents here converts into radiation, not all of them. Some of that is lost as heat. You know that when you ride, your ESC heats up, your motors heats up, and this heat is effectively lost. So it turns out there is a formula for the electric loss. That formula, again, I may be blanking on the exact character, but the formula is I², which is current, multiplied by R, which is the resistance of the circuit over time. So the resistance of the circuit is a property of the circuit itself. The battery has certain resistance and the load has certain resistance, and it's, for our case, it's just a constant. It doesn't change if we change the voltage or current. Another formula we need to know is the Ohm's law. Ohm's law says that voltage is current multiplied by resistance. So if we substitute that I² R with voltage, then we can rewrite the same formula here. We can rewrite it as U I T. Yeah, you get it? Because we substituted one of the I's and R with voltage. And let's think about what it means. That is interesting consequences. So this is a heat loss. This is a heat loss. However, in this formula, it is proportional to the square of current. And in this one, it is proportionate to just voltage. What does it mean? That means that when we increase current, if we double a current, our heat losses quadruple, because the losses are proportional to the square of current. But if we increase just voltage, then our heat losses go up twice. That's with the same power. So that means that high voltage systems result in a less heat loss, because higher the voltage, the lower the heat. The higher the voltage, the lower the current, and then lower the heat. So that's the reason why, with all the equal power, the high voltage systems will emit less heat, and therefore they are more efficient. That's it. I hope you understand now. Thank you for watching.